It's hard to believe, but Flight 7 might happen sooner than expected. While NASA previously updated the launch date for this flight, recent licensing updates and SpaceX's impressive progress could shift the timeline. So when can we expect Starship Flight 7 to launch, and how will it impact the plans that follow? Next, we'll dive into the major update NASA just shared about the Artemis Program schedule. There's plenty of big news to cover, so let's get started on today's episode of Great SpaceX. Last month, we shared an update on the launch date for Starship Flight 7, with NASA documents pointing to January 11th as the target date. This coincided with NASA and the Australian Civil Aviation Safety Authority planning aircraft observations for Starship's re-entry. At the time, it seemed clear that the flight would occur early next year, disappointing those hoping for a launch before the end of 2024. Recent developments, however, suggest this timeline could shift. On December 4th, the FCC updated SpaceX's launch license for Flight 7, extending the launch window from December 14th, 2024 to June 14th of 2025. This update leaves open the possibility of a launch happening before January 11th, as long as it occurs after December 14th. With a half-month window available in December, there is a real chance for a launch this year. Typically, FCC updates garner less attention than FAA approvals, but in this case, the FCC's decision is pivotal. According to FAA guidelines, as long as there are no procedural changes to the mission, launches can proceed without further review. Musk recently hinted that SpaceX is likely to attempt a controlled ship landing again, while the Super Heavy Catching Test and In-Space Engine Relight were already approved for Flight 6. Since no significant changes are planned between the two flights, the FAA's influence on the timeline is minimal, making the FCC's approval a critical factor. SpaceX is making rapid progress, positioning itself for a potential December launch. Booster 14 completed cryogenic testing and returned from Massey in early October, and after 2 months, it is almost certainly equipped with engines and awaiting final testing at the launch pad. The launch pad itself has been mostly cleared for use since Flight 6, aside from minor antenna issues on the tower. Ship 33 has also made significant progress. It returned from Massey over a month ago, likely after engine installations were completed. The ship is expected to undergo static fire testing at Massey next week before being transported to the launch pad. If these steps proceed without delays, integration testing could occur in mid-December, allowing for a launch by the end of the month. If SpaceX achieves this timeline, Flight 7 could launch in the 4th week of December, marking the 5th Starship flight of 2024. A launch on December 24th would not only make for a spectacular Christmas Eve event, but also represent an improvement in turnaround time, as it would come just 35 days after Flight 6 on November 19th. This will be faster than the 37-day gap between Flights 5 and 6, signaling continued progress in launch cadence. The upcoming mission will be critical for the Starship program, as it involves an attempt to catch the Super Heavy booster and perform a controlled vertical landing of the ship. Success would mark a significant leap forward, positioning SpaceX for an ambitious 2024. Depending on the outcome of Flight 7, SpaceX could repeat similar objectives for Flight 8, which aligns with NASA's planned observation, or proceed directly to catching both stages. Hardware for subsequent missions is also advancing rapidly. Ship 34 and Booster 15 are making strong progress. Construction of Ship 34 appears to be complete and is likely to begin testing after Ship 33. Booster 15, under construction since June, had its final section, the methane tank, revealed in late August. This suggests its construction was completed some time ago and is now awaiting testing. If all goes according to plan, Ship 34 and Booster 15 could launch together in January of 2025. SpaceX aims to develop a Starship refueling system by March, and at the current pace, another flight could follow in February after the January mission. Demonstrating stage catching in 2 flights would provide a solid foundation for refueling capabilities crucial to SpaceX's long-term goals and its target of 25 launches in 2025. The next few months will be pivotal for the Starship program, with rapid hardware progress, efficient testing, and streamlined launches driving a surge of activity. Whether Flight 7 happens in December or early January, it will mark a key milestone in SpaceX's mission to revolutionize space travel. A December launch adds excitement to the year's end, but what's your prediction? Let me know your thoughts in the comment section down below, and don't forget to like and subscribe for updates on SpaceX's groundbreaking journey. The future of space exploration is unfolding faster than ever. Speaking of space exploration, NASA recently announced another delay in the Artemis program schedule. Previously expected launch dates of September 2025 and September of 2026 are now outdated. Artemis 2 is postponed to April of 2026, while Artemis 3 is pushed back to mid-2027. NASA cites the need to ensure the Orion spacecraft is fully prepared, with Administrator Bill Nelson stating,
"Space is demanding, and we and our industry and international partners need this time to make sure that the Orion capsule is ready to safely deliver our astronauts to deep space and back to Earth."
The delays once again highlight challenges within NASA's systems. Despite a successful 25-day Artemis 1 mission, Orion revealed significant issues with its heat shield. Engineers spent months investigating the problem. Recently, Deputy Administrator Pam Melroy disclosed that during the Artemis 1 mission, heat accumulated in the outer layer of the heat shield during the planned skip entry, causing gases to become trapped, increasing internal pressure, and resulting in cracking and uneven shedding of the outer layer. Addressing this problem necessitates replacing the heat shield, a major factor in the Artemis 2 delay. In fact, engineers have devised adjustments to limit Orion's exposure to the temperatures that caused the heat shield issues. NASA officials stated, the updated timeline for the Artemis 2 flight is informed by technical issues engineers are troubleshooting, including with an Orion battery issue and its environmental control or life support system. The heat shield was installed in June of 2024, and the root cause investigation took place in parallel to other assembly and testing activities to preserve as much schedule as possible. While these steps aim to resolve existing challenges, they also underscore the complexity of the Orion spacecraft. Looking forward, the updated schedule now places Artemis 2 in 2026, Artemis 3 in 2027, and Artemis 4 in 2028. While still ahead of China's planned crewed lunar mission in 2030, these delays come with risks, particularly given China's rapid advancements in space exploration. NASA's aim to maintain a strong presence in cislunar space is critical for both scientific and geopolitical reasons, as Bill Nelson emphasizes.
I think we are handing to the new administration a safe and reliable way forward for us, which is to go back to the moon, to get there before China, to have presence in cislunar, which is important to our country other than NASA, and to be on the way of Moon to Mars.
These delays represent the second major schedule adjustment for Artemis in 2024, following a similar shift earlier this year. This pattern is frustrating for those eager to see the program succeed, especially given the substantial financial and time investments. However, the delays may also signify the final major decisions made under Bill Nelson's leadership. Soon, Nelson will step down as NASA administrator, with Jared Isaacman to take his place. Isaacman's appointment could signal a new direction for NASA. Known for his dynamic leadership and close relationship with SpaceX, he is well positioned to address the complexities and inefficiencies of NASA's existing systems, including Orion, SLS, and the mobile launcher, which have been criticized as overly expensive and plagued with delays. His familiarity with SpaceX, a critical partner in the Artemis program, may streamline collaboration and accelerate progress. With Starship's rapid development, there's confidence that SpaceX will meet the program's ambitious goals, keeping the U.S. ahead in the race against China. The dream of returning humans to the moon and eventually go on to Mars remains alive. What a shame. Despite all the determination, confidence, and ambitious plans, Blue Origin still seems far from reaching orbit this year. The disappointment is even more glaring compared to SpaceX, the rival they aimed to surpass, which continues its remarkable progress. How far ahead is SpaceX? Why does its success underscore Blue Origin's struggles? And how did Bezos and his team end up here? Boom! SpaceX has once again shaken the aerospace world with another electrifying static fire test of the Starship Super Heavy. This marks a crucial milestone on the journey toward the 7th flight of this colossal rocket. As scheduled, the road to the launch site was closed early on the morning of December 9th. The launch pad and surrounding area was cleared, and the orbital launch mount and launch tower were vented. By 9:15 a.m. CDT, fuel loading began. This time, the liquid oxygen tank was fully loaded, while the liquid methane tank was filled to about a third capacity. At approximately 10:19 a.m., the water deluge system activated, releasing an estimated 350,000 gallons of water, as is standard for such tests. Then, boom, the engines roared to life. Observations suggest that all 33 engines fired during this test, producing over 7,000 tons of thrust. The static fire test lasted approximately 8 seconds. Shortly after the test, the detanking process began. About 2 hours later, the road was reopened. No issues were reported with Booster 14, the launch pad, or the water deluge system, indicating a successful test. Following this critical step, SpaceX tweeted static fire of the Flight 7 Super Heavy booster. The post included videos and images showcasing the impressive test. Elon Musk added on X, getting ready for Flight 7, signaling the company's confidence in its progress toward the next major launch. With this test complete, B-14 has officially wrapped up its individual testing phase. The next step involves either rolling it back to the production site for inspection and hot staging preparation, or conducting those processes directly at the launch pad. Once the preparations are finalized, B-14 will remain at the pad awaiting its companion, Ship 33. The ship appears to have completed engine installation, with its transport stand rolled in just days ago. Indications suggest S-33 will soon head to Massey for its static fire test, possibly this weekend. Afterward, it will undergo final checks before being transported to the launch pad for full stacking and integration testing. If all processes stay on schedule, the anticipation of a 5th flight this year remains within reach. SpaceX seems poised to meet its ambitious goals, pushing the boundaries of space exploration further. According to NASA documents, the highly anticipated launch of Flight 7 is still tentatively scheduled for January 11th of next year. However, SpaceX's rapid progress leaves room for optimism that the mission might take off even sooner. Whatever the exact timing, this latest achievement represents a giant leap forward for the Starship program. It's even more impressive considering the myriad of legal and regulatory hurdles SpaceX had to overcome in 2024, especially before the successful launch of Flight 5. And speaking of hurdles, we have to talk about Blue Origin. Back when Flight 5 and Starship had yet to take flight, Blue Origin was positioning itself to launch New Glenn in October, hoping to steal the spotlight. Many thought the FAA's delays in granting SpaceX approvals might give Blue Origin a chance to beat Starship to the punch. However, despite their plans and preparations, here we are in December, and New Glenn is still firmly grounded. What's holding them back? The answer lies in the slow pace of their progress, particularly when it comes to a critical step, the static fire test. Interestingly, that's the very milestone SpaceX has just achieved with Booster 14. Allow me to repeat myself. It's December, and New Glenn has yet to conduct its static fire test. Blue Origin rolled New Glenn to its LC-36 launch pad on November 21st. Since then, it's been vertically stacked and lowered multiple times. After weeks of anticipation, Blue Origin's CEO, Dave Limp, finally addressed the delay in an update post on X. He shared a photo and video of the rocket undergoing tanking tests with liquid natural gas and liquid oxygen. Limp highlighted the massive capacity of New Glenn's tanks, nearly 30,000 cubic feet for liquid oxygen and 25,000 cubic feet for liquid natural gas, equivalent to 24 and 20 tanker trucks respectively. However, the key takeaway wasn't the technical details, it was his opening line. While we wait for regulatory approvals for hot fire and launch, they're still waiting for approval. This brings to mind the regulatory challenges SpaceX has faced time and again. Perhaps Blue Origin is now experiencing a taste of those difficulties. Earlier, journalist Christian Davenport reported that the FAA's launch license for New Glenn wouldn't be issued in November. Now, with the static fire test still incomplete, the prospect of a December launch or any launch this year is fading fast. Davenport recently provided a cautious update saying, "I'm told that it's tight, but feasible, that the FAA grants approval for a December launch of the inaugural flight of New Glenn. Blue Origin has done an exceptional job of developing their application, but there's still some work ahead." You see the pattern here? While he acknowledges the possibility of progress, phrases like "it's tight" echo his earlier remarks about November, which ultimately proved overly optimistic. At this point, Blue Origin can't lay all the blame on regulatory delays. The company's slow pace has been a recurring issue. Davenport's mention of "some work ahead" underscores this. Let's not forget that much of the hardware rolled out earlier this year was demo equipment. More time was spent testing individual systems, and the BE-4 engines, a vital component, didn't arrive and get installed until October. Add to this the repeated vertical stacking and lowering of New Glenn, which hints at unresolved vehicle and launch system issues. Per my perspective, a December launch license is highly unlikely. Even if Blue Origin receives approval this month, they're not poised to launch immediately. This means the company is likely to close out another year without reaching orbit, a disappointing outcome given their potential and resources. One positive development by the company recently is the release of an image showing the blue ring payload inside the New Glenn fairing. Accompanying the image was the statement, "New Glenn's first mission will carry our blue ring Pathfinder and is now ready for launch vehicle integration." What do you think? Can Blue Origin pull off a launch before the year's end? Drop your yes or no in the comments section down below. As we watch Blue Origin's struggles, SpaceX continues to surge ahead, setting new benchmarks in rocket development and testing. Their momentum is a testament to their relentless drive to push boundaries and redefine the future of space exploration. Before we wrap this part up, we want to thank you for being part of our journey. Last month, we hit an incredible milestone, 150,000 subscribers. Our next goal is 200,000, and we can't get there without your support. So if you haven't already, hit that subscribe button and join us in following the exciting developments in spaceflight. Your likes, shares, and comments go a long way. So for that, thank you so much, and let's aim for the stars together. Alright, back to the ongoing story of Blue Origin versus SpaceX. Recent updates highlight the stark differences in these companies' trajectories since their inception, and these disparities will undoubtedly shape their futures. Just a few months ago, many doubted SpaceX could progress so quickly toward Flight 7. At the time, some even speculated that Blue Origin's New Glenn might launch before SpaceX's 5th Starship Flight due to FAA delays. But look at where we are now. Starship Flight 5 and 6 have both launched successfully, and Flight 7 is rapidly approaching. At this point, it's reasonable to assume Flight 7 will launch before New Glenn even makes it to the pad. The upcoming Flight 7 will likely follow a similar mission profile to Flights 5 and 6. SpaceX is expected to continue refining key goals, such as catching the Super Heavy booster with the Mechazilla arms, and executing a controlled vertical landing of the Starship vehicle. However, the real standout feature of this mission is the debut of the Starship version 2. This upgraded version introduces significant changes, including alterations to its size, heat shield, and flaps. If successful, SpaceX will move closer to the ultimate goal, catching both stages with Mechazilla, achieving full reusability. From there, the company will shift focus to orbital operations, including building a refueling system to support deep space missions. These rapid advancements in just a few years stand in stark contrast to Blue Origin's New Glenn. Introduced around the same time as Starship, New Glenn has yet to make its debut. Even if it launches soon, it's unlikely to reach the same milestones as Starship within a comparable timeframe. Delays have plagued New Glenn, and if it fails to launch this year, future schedules will undoubtedly be affected. Blue Origin has repeatedly altered the schedule and mission objectives for its first 2 flights, aiming to launch ahead of SpaceX and prepare for NASA's Mars missions. But those aspirations have fallen short, creating a ripple effect on NASA's tightly scheduled missions and the many contracts Blue Origin needs to fulfill. Blue Origin's inability to reach orbit is causing frustration for everyone involved. When compared to SpaceX's relentless progress, it's hard not to see this as a significant setback, and perhaps even an embarrassment for Jeff Bezos and his team. The race appears to be over before it truly began. What's next for Blue Origin remains to be seen, but for now, the gap between the two companies is glaringly obvious.
We actually have better versions that are in production in those factories over there. There's a big version of increase that'll be flying next year. That's got the version 3 of our engines. That'll look very different.
We often focus on the evolution of Starship from V2 to V3, with much of the attention centered on the spacecraft itself. However, achieving a truly transformative new version requires significant advancements in Super Heavy, the rocket's critical booster. After a year of remarkable progress with Super Heavy, Musk has officially revealed the timeline and key upgrades for its next iteration. Meanwhile, SpaceX's Falcon 9 booster continues to set new records for reusability, offering a benchmark for the Starship booster to surpass in the future. The year 2024 has been pivotal for SpaceX, filled with both challenges and milestones. Among the most notable achievements was the successful return and capture of the Super Heavy booster by the chopstick mechanism. This marked a turning point for Starship development and set the stage for a new era in reusability. With this accomplishment and the transition to Ship V2, anticipation is building for the debut of Super Heavy V2. For now, the upcoming Flight 7 will feature a combination of Booster 14 and Ship 33. Notably, B14 is still part of the V1 design, which raises the question, when will Super Heavy V2 finally make its debut? According to Elon Musk, the answer is sometime in 2025. Development of the next generation boosters has already begun, with hardware for B15 emerging in June and B16 following in October. However, there are still questions about their design. The B15 features a longer liquid oxygen section, but its forward dome and grid fin positions closely resemble the V1 design. This suggests that B15 may not be the long-awaited V2 version. Instead, attention is shifting to B16, which appears to be the more likely candidate for the first V2 booster. Various components of B16 have already been spotted, including the common dome, liquid oxygen tank, liquid oxygen section, downcomer, aft section, and several ring clusters. The liquid oxygen section, referred to as the A4-4, is especially intriguing because it could make B16 slightly taller than its predecessors. However, the forward section, a key component that would confirm its status as a V2, has yet to appear. The assembly process for boosters remains shrouded in secrecy within Megabay 1, making it difficult to confirm details. Nevertheless, if B16 is indeed the first Super Heavy V2, it is reasonable to expect a launch in the first half of 2025. Based on the current cadence, B15 is likely to pair with Ship 34 for Flight 8, while B16 might pair with Ship 35 for Flight 9. If this timeline holds, Flight 9 could occur around April or May next year. As for the missions, while details about Flight 8 remain unclear, Flight 9 could be a critical milestone. This mission is expected to involve the first attempt to catch both the booster and the ship, a significant step toward achieving full rocket reusability. The countdown to Super Heavy V2 is on, and the excitement is palpable. Are you eager to see this next generation booster in action? Comment full V2 to share your enthusiasm. And don't forget to like and subscribe to our channel for ongoing updates on SpaceX's groundbreaking journey. When all said and done, the next iteration of SpaceX's Super Heavy booster, V2, promises significant improvements that will elevate its capabilities to remarkable new heights. During the Flight 6 launch day, Musk shared exciting details, providing a glimpse into the future of the Starship program. Musk emphasized that the new booster version is better and features big improvements with every successive version. Among these enhancements is an increase in size, as the Super Heavy V2 will be taller than its predecessor. Standing at 72.3 meters, this is 1.3 meters taller than the current version, allowing for a greater fuel capacity. This additional space will enable it to carry up to 3,650 tons of fuel, a substantial jump from the 3,300 tons held by the current model. This increase in fuel capacity is critical to supporting the enhanced performance required for future missions. When paired with the taller Ship V2, the complete Starship system will reach an astonishing height of 124.4 meters, making it an even more formidable spacecraft. The additional size and fuel will allow the booster to support heavier payloads and more ambitious missions, ensuring it remains at the forefront of space exploration technology. But the enhancements don't stop at physical dimensions. The propulsion system is also getting a major upgrade. The Super Heavy V2 will be powered by SpaceX's revolutionary Raptor 3 engines, a development that marks a significant leap forward in rocket engine technology. Earlier this year, SpaceX introduced the Raptor 3, showcasing its sleek black design and simplified structure. This new design not only reduces the potential for risks, but also makes the engine easier and faster to refurbish, a key factor in achieving rapid reusability. The streamlined manufacturing process will allow SpaceX to produce engines more efficiently, meeting the increasing demand for Starship launches. Most notably, the Raptor 3 engines offer significantly greater thrust. Each engine is capable of producing 280 tons of thrust, a dramatic improvement over the previous version. With 33 Raptor 3 engines, the Super Heavy V2 will deliver an incredible 9,240 tons of thrust, or approximately 20.37 million pounds. To put this into perspective, the level of power is 2.6 times greater than that of the Saturn V, the rocket that once carried astronauts to the moon. Such extraordinary thrust levels will enable Starship to carry out even more ambitious missions, including those that involve traveling to distant planets. Elon Musk has also hinted that this is just the beginning. SpaceX plans to push the capabilities of the Raptor 3 engines even further, with a goal of achieving 300 tons of thrust per engine. If this target is met, the Super Heavy V2 could reach a mind-blowing 9,900 tons of liftoff thrust. While this milestone may take some time to achieve, it reflects the ambitious vision that SpaceX has for its Starship program. Incremental advancements like these will continue to propel the company toward its ultimate goal of making space travel more accessible and sustainable. In addition to the major upgrades to its engines, the Super Heavy V2 will incorporate several other refinements to enhance its performance and reliability. For instance, the grid fins on the booster will be repositioned to a lower point. This adjustment is expected to improve stability and control during flight, addressing issues identified in previous launches. Furthermore, the hot staging system will undergo a redesign, with the addition of a longer ring and larger vents. These changes will simplify the system's design while improving its efficiency during stage separation. The new hot staging ring is also expected to be reusable, aligning with SpaceX's commitment to reducing costs and minimizing waste. To support these upgrades, SpaceX is also making improvements to its infrastructure. Reports suggest that the new launch tower, while maintaining the same number of segments, will be slightly taller to accommodate the increased height of Starship V2. This upgrade will ensure that the launch infrastructure is fully compatible with the enhanced booster and spacecraft. The tower is expected to be completed by January next year, aligning with the anticipated launch schedule. The Super Heavy V2 represents a pivotal step toward achieving SpaceX's long-term goals. The journey to a fully reusable next-generation spacecraft is well underway, and the Super Heavy V2 will undoubtedly play a central role in making this vision a reality. Wrapping up the discussion on Super Heavy V2, let's shift our focus to the Falcon 9 booster, which continues to achieve remarkable feats. On December 4th at 5:13 a.m. Eastern, SpaceX launched a Falcon 9 from SLC-40 at Cape Canaveral, successfully delivering 24 Starlink satellites into low Earth orbit. These satellites were deployed just over an hour after liftoff, helping SpaceX achieve a significant milestone, surpassing 7,500 launched satellites. Of these, approximately 6,800 are currently in orbit, with 6,000 actively operational, a testament to SpaceX's dominance in satellite deployment. The records didn't stop in space. Notable achievements were also made on the ground. 8 minutes after liftoff, the Falcon 9 booster B-1067 made a pinpoint landing on the drone ship A Shortfall of Gravitas. This marked the 377th successful booster landing in SpaceX's history, further solidifying the company's unmatched expertise in rocket reusability. For B-1067 specifically, this mission marked its 24th landing, breaking its own record of 23 and setting a new benchmark in rocket reuse. Previously, boosters like B-1061 and B-1062 had also tied at 23 landings, but both have since been retired. This milestone underscores SpaceX's pioneering reuse strategy. which continues to set it apart from the aerospace industry. Additionally, B-1067 set a personal turnaround record, completing its latest mission just 23 days after its previous launch. This surpassed its earlier record of 33 days and stands as one of the fastest turnaround times among the Falcon 9 fleet. While the fastest turnaround time remains at 14 days, achieved by B-1080 on November 25th, B-1067's performance highlights the incredible efficiency of SpaceX's operations. These achievements exemplify SpaceX's leadership in aerospace innovation. They also set the bar for Starship, as Super Heavy and Starship themselves aim to match and surpass these milestones in the near future. Stay tuned for what's to come. Full reusability. Achieving full reusability has always been SpaceX's ultimate goal for Starship. This ambitious vision requires every part of the system to be recoverable and reusable. While much focus is placed on the reusability of the Super Heavy booster and the Starship itself, another critical component garnering significant attention is the hot staging ring. Recently, SpaceX made a surprise recovery effort for this key part, signaling a potential breakthrough in making it reusable in future missions. So how are these recovery efforts progressing? What upgrades is SpaceX planning for the system in the future? Starship is continuously evolving, becoming bigger and more powerful over time. To create such giants, many aspects of its design and construction have changed, particularly the welding methods used in its assembly. With new versions on the horizon, including the highly anticipated V3, it's a great time to look back at the evolution of these welding techniques and explore what upgrades we might expect in the upcoming version. So how have these welding methods progressed, and how will they continue to evolve alongside Starship's development? The massive Starship rocket, a symbol of SpaceX's vision for interplanetary travel, is not a monolithic structure, but rather composed of meticulously assembled stainless steel rings. These rings are welded together into segments and then stacked using advanced welding techniques. While welding might seem like a straightforward process, its execution is anything but simple, requiring precise methods and careful attention to detail. Elon Musk has often highlighted the critical importance of welding in the construction of Starship, stating, "A lot of ways to melt and join steel, mostly just needs to be welded consistently and with precise parts." This precision becomes even more vital when using stainless steel instead of the carbon fiber utilized in Falcon rockets. Stainless steel offers several advantages, including lower cost, greater durability, and versatility in shaping. However, it also presents challenges, particularly in its tendency to retain heat, which can complicate the welding process. In the early stages of Starship development, SpaceX employed the flux-cored arc welding method, or FCAW. While functional, this approach had its limitations. Early Starship prototypes appeared rough and unsophisticated, with visible welding seams and traces. The high heat generated by FCAW caused the stainless steel to warp and deform, resulting in an uneven surface. Additionally, stainless steel is prone to scratching, making it impossible to grind down the weld marks for a smoother finish. These issues were not merely aesthetic, they posed real structural risks. Imperfect welds could lead to cracking during the rocket's operation, particularly during the intense stress of atmospheric re-entry. Such vulnerabilities could compromise the integrity of the weld and jeopardize missions. Recognizing these shortcomings, SpaceX transitioned to a more advanced welding method called TIG-TIP, or TIG-tip semi-automatic welding. This technique provided significantly greater control over the welding process, resulting in cleaner, more uniform seams. Musk himself highlighted the benefits, explaining, "These parts are stamped versus manually bumped formed and TIG-tip welded versus flux core. Higher precision, stronger joints, and 20% mass reduction." The advantages of TIG-tip welding extended beyond aesthetics. The method produced stronger welds, reducing operational risks and allowing for thinner stainless steel rings. With fewer welds required, Starship's overall mass decreased by up to 20%, a critical improvement for a spacecraft designed to carry large payloads and traverse extreme environments. SpaceX didn't stop there. They continued to enhance their manufacturing processes by introducing laser welding machines. These automated systems significantly increased precision, further improving the strength and appearance of the Starship prototypes. This progression is especially evident when comparing the nose cones of early prototypes with those of more recent iterations. The newer prototypes boast a sleek, polished look, free of visible weld marks while benefiting from faster and more efficient production cycles. Another crucial upgrade in Starship's evolution was the transition from 301 stainless steel to 304L stainless steel. This newer alloy offered improved corrosion resistance, a critical factor for both manufacturing and operation in space's harsh conditions. The enhanced composition of 304L made the welds up to 4 times stronger than before and increased the material's ductability by 25% at extreme temperatures. Additionally, its low carbon content helped to prevent cracking, further enhancing the rocket's reliability. These advancements represent a culmination of SpaceX's relentless pursuit of excellence. By refining their welding techniques and upgrading materials, SpaceX has transformed Starship into a spacecraft that is not only visually impressive, but also exceptionally strong and durable. The combination of precise welding, advanced materials, and automation has paved the way for a rocket capable of withstanding the demands of deep space exploration. Starship's journey from rough early prototypes to its current state is a testament to SpaceX's innovative spirit. Each improvement in welding methods and materials brings humanity closer to realizing the dream of sustainable space travel. Through these advancements, SpaceX continues to set new standards in aerospace manufacturing, proving that no detail is too small when building the future of interplanetary exploration. SpaceX is now taking the technologies and lessons learned from earlier versions of Starship and applying them to its new iterations, pushing the limits of innovation even further. Currently, SpaceX is in the process of producing Starship V2, incorporating several design changes and laying the groundwork for the upcoming V3, a colossal version anticipated to reach a towering height of 150 meters. In these new versions, durability remains the top priority. As Starship aims to venture deeper into space rather than just reaching orbit like V1, it will face increasingly harsh conditions. Re-entry processes in particular will expose the ship to extreme temperatures, demanding robust design and materials. After 6 flights, Starship V1 has demonstrated steady improvements, especially in handling the challenges of re-entry. However, full recovery remains elusive, highlighting the need for further advancements in production methods. Encouragingly, the early prototypes of V2 exhibit notable enhancements. A side-by-side comparison of the nose cones from V1 and V2 reveals a significant upgrade. The welds on V2 are practically invisible, giving the impression of a seamless single block. This not only suggests improved durability, but also highlights advancements in welding technology. But durability is just one part of the equation. SpaceX is also focused on reusability, striving to ensure their rockets can perform multiple flights. Enhanced welding methods will play a crucial role in achieving this, as they reduce structural stress and streamline refurbishment processes. Another critical advantage of the new welding methods is speed. With significantly increased automation, production times have seen a dramatic boost. The first prototype of V2, Ship 33, was built in just 42 days, a testament to SpaceX's commitment to efficiency. However, the true effectiveness of the V2 welding techniques will be tested in actual flights, beginning with Flight 7 early next year. These flights will provide essential data for further refinements, paving the way for the development of V3. Once the welding and production principles stabilize, SpaceX's next step will be replication on a larger scale. That's where Star Factory comes in. It's already operational, producing parts continuously. To meet the demands of mass production, additional welding systems may be needed, alongside expanded facilities like the planned Gigabay. This new assembly bay will be taller and wider, capable of accommodating the larger Starship versions down the pipeline. Regarding deployment schedules, SpaceX has ambitious plans for both Starbase and its Florida facilities, which are expected to utilize V3 versions. NASA has stated that Starship will move to Florida operations once it achieves a cadence of 1 launch per week, a milestone likely to occur early next year. To meet these goals, preparations for the production system, including welding technologies, are essential and must be addressed now. SpaceX's ultimate vision is to produce 1 Starship per day, necessitating round-the-clock operation. Continuous advancements in welding and overall production methods will be critical to achieving this target. Beyond production, SpaceX is enhancing its testing and launch systems to complement its manufacturing capabilities. The Flame Trench test system, already operational, has proven highly effective. This innovation allows SpaceX to increase its launch rate, with newer prototypes often ready before previous versions have ever flown. Significant upgrades are underway at the launch site, including the addition of Launch Tower B and a new orbital launch mount. These systems are key to increasing Starship launch frequency and eventually catching the rocket. They are expected to be replicated as Starbase expands and new launch facilities like those in Florida are established. SpaceX is building an unprecedented system that integrates advanced production, rigorous testing, and cutting-edge launch capabilities. Every detail, no matter how small, supports the broader vision. One day, Starship will take humanity to the moon and Mars, achieving what once seemed impossible. These milestones will rest on countless smaller innovations, such as improved welding techniques that strengthen its foundation. What do you think of SpaceX's Starship development, especially the evolution of its welding methods? Share your thoughts in the comment section down below, and don't forget to like and subscribe for updates on SpaceX's incredible journey. Wrapping up that whole segment with Starship, let's shift our focus to an exciting update on Varda Space Industries and their recent milestone, a significant $48 million contract awarded by the U.S. Air Force Research Laboratory, otherwise known as AFRL. Varda Space Industries is well recognized for its innovative work in developing and operating re-entry capsules designed to return specialized cargo from space. Earlier this year, in February, Varda successfully completed its first mission, W-1. This mission marked a groundbreaking achievement, the safe return of a capsule carrying pharmaceuticals created in a microgravity environment. The capsule re-entered Earth's atmosphere at a blistering 18,000 miles per hour, or around 29,000 kilometers per hour, and executed a precise landing in the Utah desert using a parachute system. Building on this success, the AFRL contract underscores the increasing interest in commercial re-entry vehicles for cutting-edge military applications. This partnership specifically aims to test military payloads at hypersonic speeds, a notoriously complex challenge in aerospace engineering. Hypersonic testing involves navigating extreme thermal protection, maintaining accurate navigation, and ensuring reliable sensor performance, all critical components for the next generation of defense technology. The collaboration is also a cost-effective solution for the U.S. Space Force, as it provides a controlled, real-world testing environment without the steep expenses associated with traditional hypersonic vehicles. Varda's expertise in capsule design and hypersonic re-entry positions them as an ideal partner for this initiative. Under its new contract, Varda is set to launch its W-2 mission in early 2025, featuring the Varda Hypersonic Test Bed Vehicle with the AFRL's Osprey spectrometer payload. Osprey will collect vital atmospheric data during high-speed re-entry, advancing science and defense technologies. This collaboration highlights the growing potential of commercial military partnerships in space innovation. Stay tuned as Varda pushes the boundaries and refines its cutting-edge systems. Cancel the SLS. It's an idea that has been on many minds for a long time, with some believing it should have happened much sooner. Now, this possibility seems closer than ever as NASA prepares to enter a new era. Recent updates highlight the impact NASA's current system has had on the Artemis schedule, sparking discussions about the need for change. This shift could also be the moment for Elon Musk and SpaceX to step up and take on an even more significant role. For over a decade, NASA's space launch system has been in development, costing tens of billions of dollars. Despite this monumental investment, it has only completed a single flight, an uncrewed mission. This alone highlights the profound disappointment surrounding the program. The SLS has already consumed more than $11 billion by the time Artemis 1 launched, and it continues to demand significant resources. The system's inability to be reused is a glaring drawback, forcing NASA to manufacture an entirely new rocket for each mission. NASA has poured billions into other related systems, such as the Orion spacecraft and the mobile launcher. However, these projects have also been fraught with issues. Orion's heat shield problems, the mobile launcher system has suffered extensive damage, requiring lengthy repairs but offering little long-term potential. Adding insult to injury, NASA reportedly lost an additional $4 billion just to launch a single mission. Journalist Eric Berger, known for his accurate insights into NASA's activities, reported a 50-50 chance of the SLS being canceled in earlier updates. More recently, he updated that the probability has increased to 75 to 25, signaling growing consensus that the program is unsustainable. Berger's statement, "Not Block 1B, not Block 2, all of it. There are other ways to get Orion to the moon," Given the vehicle's underwhelming performance over the years, its survival rate seems appropriately low. The U.S. aerospace industry is poised for a transformative shift. With the recent election of President-elect Donald Trump, billionaire Jared Isaacman has been nominated as NASA's next administrator. Isaacman, known for his dynamic leadership and business acumen, represents a sharp departure from current NASA leadership. Isaacman brings a wealth of experience to the role. He is not only a successful entrepreneur but also an accomplished astronaut. As the commander of SpaceX's Polaris Dawn mission, he has first-hand experience in human spaceflight. He also has a close relationship with SpaceX, having sponsored private Dragon missions and supported the company's groundbreaking advancements. This unique combination of business mindset, industry expertise, and enthusiasm positions him as a leader who could reshape NASA's priorities. It seems unlikely that Isaacman would allow a problematic program like the SLS to persist, especially given its lack of efficiency and exorbitant costs. A decision to cancel the SLS could be made shortly after he takes office. Further compounding the program's struggles is NASA's recent announcement of additional delays in the Artemis schedule. Artemis 2, originally planned for September of 2025, has been pushed to April of 2026, while Artemis 3 has shifted from September of 2026 to mid-2027. This marks NASA's second delay of 2024, pushing the Artemis timeline 2 years behind earlier projections. Such setbacks threaten the U.S.'s position in the lunar race, especially as China makes significant strides in its space ambitions. The likelihood of canceling the SLS appears even higher than Berger's 75% estimate, though it is reasonable to assume NASA may proceed with Artemis 2 to avoid wasting existing investments. The possibility of the SLS being canceled feels almost inevitable. What are your thoughts on this? Place your bets in the comment section down below, and don't forget to like the video and subscribe to our channel to stay updated on SpaceX's development journey. If the SLS were canceled, what could realistically replace it? Many would point to SpaceX, given its advancements in rocket technology, but relying solely on one company raises concerns about monopolization. To avoid dependence on SpaceX, some propose a collaborative approach involving multiple aerospace companies. For instance, Blue Origin's New Glenn could launch the mission from the ground to orbit, after which Orion would separate and dock with Vulcan's Centaur upper stage to proceed to lunar orbit. There, the crew could transfer to SpaceX's Starship human landing system as originally planned. However, this approach introduces significant logistical challenges requiring readiness and coordination from multiple companies. As it stands, New Glenn has yet to conduct its maiden flight, while Vulcan has only flown twice, still grappling with technical issues. Moreover, both Blue Origin and ULA have extensive backlogs of missions to address. This leads to the more straightforward option of relying solely on SpaceX's vehicles. Several possibilities exist here. SpaceX could use Falcon Heavy to launch Orion into orbit from where it would follow its planned trajectory to the moon. Alternatively, Falcon Heavy could place Orion in Earth orbit, allowing the crew to transfer to Starship HLS for the remainder of the mission. A third scenario involves Falcon Heavy launching Orion and a ULA upper stage to send it into lunar orbit, where the crew would transfer to Starship HLS. Yet challenges remain with this option as well. Compatibility between Falcon Heavy and Orion could be an issue, and Starship HLS would require upgrades to handle expanded mission roles. Additionally, SpaceX's orbital refueling system, essential for these missions, has yet to be fully developed. Despite these hurdles, relying on SpaceX appears to be the more promising option. SpaceX's vertical integration ensures greater continuity and reliability, especially if NASA considers replacing Orion with Dragon. Dragon has already demonstrated its reliability and could be upgraded for lunar missions. Alternatively, Dragon could act as a crew transfer vehicle in Earth orbit, facilitating missions with Starship HLS. As for Starship itself, it continues to progress rapidly. In just 1.5 years, SpaceX has achieved controlled landings for both stages of the vehicle, a timeline much shorter than the SLS development. The company has also recovered Super Heavy using the groundbreaking Megazilla arm. Looking ahead, SpaceX plans to refine this system further, ultimately enabling both stages to be caught and reused. Refueling technology is also on the horizon, promising to revolutionize deep space missions. If the SLS is indeed cancelled, SpaceX's role in lunar and interplanetary exploration will inevitably grow. This would demand that the company accelerate its timeline towards stable operations and develop its refueling infrastructure. Next year's planned ship-catching mission will be a critical milestone toward achieving full reusability, something the SLS and other traditional rockets cannot accomplish. Full reusability would drastically reduce costs, enabling more frequent missions and laying the groundwork for Moon and Mars exploration. SpaceX is already planning to ramp up Starship launches next year, aiming for up to 25 flights, about 2 missions per month. This increased cadence will allow SpaceX to refine its systems, improve reliability, and transition to stable operations. Based on NASA's Artemis timeline, SpaceX would then have an additional 1.5 years, spanning 2026 and the first half of 2027, to further increase launch frequency and readiness before the official Artemis mission in mid-2027. In tandem with this effort, SpaceX will work on developing its orbital refueling system. While this poses significant technical challenges, SpaceX's track record suggests it is well equipped to succeed. The company has already achieved remarkable feats such as vertical booster landings and catching boosters with Mechazilla. With extra time for development, SpaceX has the potential to revolutionize space travel. Next year may also see the debut of SpaceX's HLS prototype. Early designs for the crewed version have been released, showcasing significant promise. This prototype will serve as a key step in demonstrating Starship HLS's capabilities for NASA's Artemis program. In conclusion, if the SLS is cancelled, SpaceX seems best positioned to take on its role, thanks to its advancements in reusable rocketry, rapid development cycles, and integration of critical systems like orbital refueling. Collaborative approaches involving multiple companies face substantial hurdles, making SpaceX's streamlined solutions more appealing. What do you think would be the ideal replacement for the SLS? Share your thoughts in the comments section down below, and don't forget to like and subscribe to stay updated on SpaceX's groundbreaking journey. We'll need to wait for NASA's leadership transition to see what happens next. While not yet certain, all signs point to the SLS nearing its end, largely due to the long-standing issues it has created. Fortunately, SpaceX remains a vital force in the U.S. aerospace industry, poised to take on an even greater role. With Elon Musk and his team stepping up, we can anticipate a stronger collaboration between NASA, the organization that first sent humans to the moon, and SpaceX, the company positioned to do it again. This partnership is essential to reclaiming lunar leadership. Do you agree? Surprise, everyone! The concept I thought had faded, spin launch, is making a surprising comeback. Recent updates, especially from their CEO, revealed bold ambitions to rival SpaceX. With renewed focus and big plans, spin launch is working to establish itself as a serious competitor in the space industry. So how far has spin launch come? Are their ambitions enough to challenge SpaceX? Spin launch, founded in 2014, is pursuing a revolutionary approach to achieving orbit, using kinetic energy through a groundbreaking accelerator system rather than traditional rocket propulsion. While the concept holds immense promise, it also faces substantial challenges, including overcoming technical limitations, earning community support, and competing with the ever-advancing rocket industry. At one point, it seemed like the project might falter or pivot to less ambitious objectives, but recent developments suggest otherwise. The company has secured fresh funding to fuel its vision. A recent filing with the U.S. Securities and Exchange Commission reveals that Spin Launch closed a fundraising round at $11.5 million, with a total offering target of $25 million. Although this figure is smaller than the $71 million raised in its 2022 Series B round, it represents a critical step forward. David Wren, Spin Launch's new CEO, expressed optimism, stating that the funding will enable the company to advance its plans and set the stage for greater achievements in the future. One of Spin Launch's boldest ambitions involves creating a satellite constellation that could rival SpaceX's Starlink. In 2021, the company submitted a proposal to the FCC for a network of nearly 1,200 satellites, designed to deliver high-speed broadband services globally. While the FCC has yet to grant approval, this move signals a decisive shift: commercialization. A successful satellite network could generate substantial revenue, positioning Spin Launch as a competitive player in the space industry. Meanwhile, the company remains deeply committed to refining its accelerator technology, a revolutionary system designed to dramatically reduce the cost of reaching orbit. Spin Launch aims to launch 200-kilogram payloads into orbit for just $250,000 to $500,000 per mission. a fraction of the cost of traditional rockets. The system also promises a remarkable frequency of 5 to 10 launches per day, far exceeding any current rocket capabilities. After years of development, Spin Launch conducted 9 successful suborbital launches in 2022, bringing its total to 10. However, challenges in scaling the technology and resolving logistical issues have slowed its progress. Now, with renewed focus and funding, Spin Launch appears poised for a breakthrough. A decisive step in this resurgence involves plans to build an orbital-class accelerator on Adak Island, Alaska. Spin Launch currently operates 2 accelerators, a 12-meter system in California and a 33-meter version in New Mexico, both used for suborbital testing. To achieve orbital launches, the company needs a 100-meter diameter accelerator, 3 times larger than its New Mexico facility. Alaska offers logistical and geographic advantages, but this is not Spin Launch's first attempt to establish such a site. A previous effort in Hawaii failed after the company struggled to meet local expectations for job creation, infrastructure investment, and long-term community benefits. Negotiations for the Alaska site began in 2023, and the company is optimistic about reaching an agreement. Spin Launch's renewed momentum also coincides with significant leadership changes. In May, David Wren, previously the company's COO, was named CEO, succeeding founder Jonathan Yaney. This leadership transition marks a new chapter for Spin Launch, with Wren bringing extensive expertise in engineering, system architecture, and business strategy. As VP of Technology, Wren led the company's engineering team and played a crucial role in fundraising efforts, making him well-equipped to guide Spin Launch through its next phase. In his first statement as CEO, Wren expressed his enthusiasm for the company's mission. With the company's experienced leadership and incredibly talented team, I am confident in our ability to execute our goals and bring our integrated tech stack of low-cost space solutions to market. His leadership is reinforced by the ongoing support of Yaney and board members Greg McAdoo. McAdoo emphasized the company's strong foundation and momentum, stating, "Spin Launch's unwavering dedication to excellence and innovation has positioned the business for long-term success. With immense energy and a strong base to build upon, I look forward to supporting David and the team as they enter this next phase of evolution." With an experienced leadership team in place, Spin Launch is intensifying its fundraising efforts to support both the orbital accelerator and satellite constellation, advancing its mission for low-cost, sustainable space solutions. However, Spin Launch faces significant challenges competing with the established rocket industry led by SpaceX. Rockets have become more reliable, versatile, and cost-effective, setting the standard for space launches. Spin Launch must prove that its innovative approach can match this reliability while offering clear advantages in its cost and scalability. If successful, it could carve out a unique niche, but the challenges and timeline remain uncertain. The space community is watching as Spin Launch's kinetic launch technology aims to disrupt the industry. To succeed, the company must overcome significant engineering challenges, secure funding, build infrastructure, and gain regulatory approval. Spin Launch embodies the innovative spirit of the modern space race, challenging norms with its focus on affordability and sustainability, key demands for cost-efficient, eco-friendly space solutions. If successful, it could redefine orbital access, establishing more frequent and accessible missions. What's your take on Spin Launch's progress? Can it overcome these challenges to revolutionize the space industry? Share your thoughts, yes or no, in the comments section down below. Don't forget to like the video and subscribe for updates on Spin Launch, SpaceX, and other groundbreaking developments. It's undeniable that Spin Launch has made bold efforts to innovate in the aerospace industry, but it seems unlikely these strides will change their position in the near future. To start, their recent $11.5 million fundraising effort is far from sufficient for their ambitious goals. Constructing an operational orbital-class accelerator system with a diameter of 100 meters will require significantly more resources. The sheer scale of such a project, combined with the technical hurdles involved, underscores the funding gap Spin Launch faces. Spin Launch's track record also raises concerns. While their system is described as capable of suborbital launches, their 10 test flights to date have reached only 10 kilometers in altitude and speeds of 1,600 kilometers per hour, far below the requirements for orbital launches, which demand altitudes of at least 300 kilometers and speeds exceeding 25,000 kilometers per hour. Even if they can close this gap eventually, their progress so far suggests a steep uphill climb. Now, let's compare spin launch's concept to the well-established rocket industry. SpaceX alone highlights the disparity. As of this year, SpaceX has completed over 100 launches, bringing their total to more than 400 with a steadily increasing cadence. Each Falcon 9 flight can carry over 22 tons to low Earth orbit, over 100 times the payload spin launch aims to deliver with a single mission. Falcon Heavy, while less frequently launched, is even more capable, handling up to 63.8 tons to LEO, more than 300 times spin launch's target. Looking ahead, SpaceX's Starship looms as an even greater competitor. Designed to carry up to 200 tons to LEO and planned for daily launches, Starship's capabilities could outclass spin launch's payload capacity by a factor of 1,000. Moreover, with a projected cost of $2 million per Starship flight, SpaceX could achieve a cost per kilogram of $10, far below that of spin launch's $1,250 per kilogram, assuming $250,000 per 200 kilogram mission. This vast disparity in payload and cost will make it increasingly difficult for spin launch to compete effectively. And SpaceX isn't spin launch's only competitor. Other companies, such as Rocket Lab, Blue Origin, and ULA, also operate reliable systems with demonstrated capabilities. Additionally, the rocket industry is entering a growth phase, driven by burgeoning lunar and Mars exploration missions, further raising the bar for competition. Beyond capability and cost, spin launch faces inherent limitations. Its launch mechanism, relying on extreme centrifugal acceleration, risks damaging sensitive payloads and cannot accommodate liquid fuel payloads. These drawbacks could deter potential customers, especially when established rocket options are available. Spin Launch's satellite constellation plan also faces significant hurdles. With only 1,190 satellites in its proposed system, it falls far behind SpaceX's Starlink. SpaceX has launched over 7,500 Starlink satellites, with more than 6,800 in orbit and 6,000 operational, and Starlink is far from finished. SpaceX plans to grow the constellation to 12,000 satellites, with the potential for 40,000 pending international approval. The size disparity is just one part of the picture. Starlink has already proven its value by generating revenue for SpaceX, enhancing live-streamed Starship reentries, and providing critical connectivity during disasters. These accomplishments highlight Starlink's established role, leaving Spin Launch's nascent system struggling to compete, even if it eventually becomes operational. The competition doesn't stop with SpaceX. Established constellations like OneWeb and Amazon's Project Kuiper also pose challenges, intensifying market pressure on Spin Launch. While Spin Launch's concept is bold and innovative, the challenges ahead are formidable. From securing funding and achieving technical success to navigating fierce market competition, the hurdles remain significant both before and after the system launches. Spin Launch's ambition to blaze an uncharted path deserves recognition. Their vision holds promise, and their drive to innovate is commendable. However, realizing that vision will require overcoming substantial technical, financial, and competitive obstacles. Only time will tell if Spin Launch can meet these challenges and carve out a lasting role in the aerospace industry. Well, folks, that's about it for today's episode. Thank you so much for tuning in, and as always, this has been Kevin from Great SpaceX. Until next time, keep looking up.